How's it going, folks? Today we are going to talk about ES6. What is ES6? It's kind of the blanket name meant to encapsulate most of the JavaScript changes that have happened over the past 5 or 6 years. ES6 is named because it was like supposedly the sixth release of ECMAScript. What's ECMAScript? Well, ECMAScript is what JavaScript is based on. So when they release something, JavaScript tends to follow it. There's a lot of things that came out in ES6. Then there was ES7, the next year ES8, 9, etc. They all added a bunch of things. But all of these things are kind of grouped under a single umbrella, ES6, because they all serve a similar purpose. What is that purpose? Well, they're what we call syntactic sugar. They make our lives easier as developers, but they don't really add any new functionality that wasn't already there. So let's start out with the first one, which is template literals. So let's say we have a variable name, and then we have age. No, let's put my actual age. So we've got some variables. We want to actually do a hello string. So what we want to say is something like hello string equals hello, Robert, you are years old. But we have variables, so let's put those variables in here. Now, what we would need to do with this string is we would need to actually use concatenation. So we have a string, we say plus. We have another string, whoops, not equals. Age, like that. And so now this is saying this string plus this variable, plus this string, plus this variable, plus this string. And it's going to smash them all together into one single string. So if I console log this hello string, you can see now it's put my name in here, and it's put my age in here. But this is kind of annoying, because you have to do a lot of quotes and a lot of pluses, and occasionally you get it wrong, like you saw that one time I typed in equals. Also, if you're here and you do quotes, it puts 2 and you have to delete one of them. It's just a pain. So what can we do with that? Well, string 2, we have what's called template literals. Now, template literals are like strings, but they're a little different in a couple ways. First one is they don't use quotes, they use backticks. Where is this backtick? It's right below, on my keyboard, it's right below my escape key on the top left of the keyboard. So here I can just put any text in a string just like that. So let's console log that. And you can see it behaves just like a regular string that you do with quotes. So now let's put our hello. You are 3 years old. And now let's put some variables in here. We can actually do that same concatenation. Okay. Like this. And if I run this now, you can see it does the same thing. But we don't have to, because template literals have a special power. If I put a $sign and then 2 curly braces, open and close, and I put the variable in here, it also puts the value of that variable inside that string. And I could do the same thing with the age, just like that. Pretty cool, huh? But here's the real power of template literals. We're putting a name in here, right? This can be any JavaScript statement. Okay, so I can actually do something like string 3 equals template literal I am, and then let's do a ternary. Okay, age greater than 65, whoops, 65, retired, not retired. Oops, this actually needs to be question mark. So what does this ternary do? Basically, if my age is above, this is a simplified version of an if statement. If age is greater than 65, it's going to go with this option. Otherwise, it's going to go with this option. So if I run string 3 again, it says I am not retired, because I'm not. But if I change my age to 70, it says I am retired. So that's an example of, you could just put any JavaScript in here as long as it returns a value. So we can put other things in this as well. Like let's say we wanted to do a math equation. Math.floor 60 divided by 2.4, right? We can run that. And you can see it runs this code. So any JavaScript code that returns a value can be put inside these two curly braces, which, you know, is pretty powerful, I think, anyway. All right. So that's template literals. Let's talk about let and const. Let and const are new variable types. You can see we're using const here. So normally we had like var, right? We're familiar with var. Now, var has a bit of an issue, though. If I do something like for, well, let's see. If I say if true var blah equals 45 console.log blah, and then outside here I again console.log blah, I run that, you can see it logs out here. Why is that, though? That's kind of weird, right? Because we define the variable inside this if statement. Why would it be available out here? Well, JavaScript does something called hoisting to variables. So what it actually does is when it sees a var, it redeclares it at the top level scope and then does this. We don't always want that because it causes leakage. Sometimes you want a variable to just be inside an if statement or a for loop because that's the only place you want it to be, and you don't want it to leak outside. Particularly, let's say if we had something like this, item equals item 1, items equals item, and then item 2, item 3. Actually, let's do this. We're going to do vars with all these. See, const is a habit for me. Then I do a for loop over items, and I say var item, items I. What is the value of item at the end of this? Well, you'd expect that this block is self-contained and doesn't mess with these other variables. So item should still be item 1. But if we run this, you can see it's actually item 3 because of that hoisting. JavaScript always makes the variables defined at top level. We don't like that. That's bad. So what we can do instead is we use let or const. Let doesn't have that problem. So if I change everything here to let, and then I rerun this, now you can see it says item 1 because this variable is not the same as this variable. And I know it's a little confusing. What is const then? Oh yeah, so that's why we use let, because let is properly scoped to the block that it's defined in. It doesn't leak outside of the block, and that's just better practice because it makes things easier for us to deal with. What about const? Const is something that can't be changed. So if I change this to const and then I say items equals empty array, and I run that, it fails. It says assignment to constant variable on line 5. Because as soon as you set an item, as soon as you set the variable that's constant, you can never reset it. Why do we want to do that? Well, sometimes we have something like, let's say I want const access token secret token. Okay. I don't want that to ever change. As soon as I set that in the program, that should never change. Because if it does change, it means that some things might stop working because the access token is changed. So if I put this in here and someone else later comes along and says access token equals some other token, this is going to give an error, and that's going to tell them, hey, you did something wrong. You're not supposed to do this because this is a constant variable. Const is really useful. Like you could see when I was doing my definitions, I do const by default. You only do let if it's something that you're planning on changing or modifying. What's next? Arrow functions. So we've had functions, right? Or methods. Function equal const my method equals function, and we take in, like, let's say a, and we return a times 2. Right? And then if I console log my method 4, I should get 8. And there I do. This is what we call an anonymous function. It has no name. It must be assigned to a variable to do anything to work. Or likewise, if we're passing something in, so maybe we have do action, and we have variable and a callback. We can return callback variable, where callback is actually a method. So now I would say result do action, whoops, do action for, and then function a, oops, return a times 2. This is another way that we can handle this. Oops, I misspelled it. Where this is an anonymous function being passed in as a argument to another function that's going to call it. This is very common. And if I log this result, it should again be 8. This is really common. And it's useful for a lot of reasons, but there's actually a shorter method. So let's just look at my method again. Method equals function a, return a times 2. And now I'm going to show you what an arrow function looks like. 2 equals a little shorter, right? So at this point, we don't need the function keyword. And we have this instead, this little arrow here. And that's just what JavaScript knows. Okay, this is an arrow function. We've got our parameters in the parenthesis, just like we've done before. And we've got our return, our function body, and our return value. These two methods pretty much do the same thing. So why would we use an arrow function? Well, for one, it's less typing. There's less keys you have to hit. For another, it has a couple of special properties. Okay, so let's take a look at some of them. So if we want to bind, this has to go a little bit into context, but basically an arrow function retains the context it had when you created it. What does that mean? If I console log this, and then in here, and then I call this method 2, you can see that it's empty. What does that empty mean? That means the top level context. It's a global scope context. If I do this with my method, and I say, okay, console.log this, it gives us something a little bit more complicated because that's also a global scope object. If we put it in object, method, let's see, name, Bob, method. So let's do this as a function first. Console.log this.name. Okay. Now if I call object method, let's actually take this out. We get Bob because this refers to the object and name refers to the name. If I make this an arrow function, we get undefined. Why? Because this is not object. The arrow function was created at top level scope, which means that this property is set. It's set by default. Why do we want to do that? Well, this becomes really useful when we're talking about constructor functions and event handling. So let's actually turn this into a constructor function. And so I'm going to say new object. If you haven't gone over constructor functions yet, that's okay. You might want to watch that video before doing this. So we have a constructor function. This.name equals Bob. This.method equals arrow function again. Console.log this.name. Object.method. Well, now it gives us Bob. Why does it give us Bob? Well, because now the context in which this arrow function is created was the object. And it holds on to that. Why is this useful? Because if you handle an event listener on a browser, for instance, and you pass in, so you'll say like element add event listener click function here, right? What is the context of this function? Well, it's the element that got clicked. Sometimes we don't want that. Sometimes we actually want, so for example, let's say I had id, I had some element that was passing into object, and I wanted to actually be able to add something onto it. If I say event listener click function, and then I console log this .name, it's going to give me undefined again. But why? Because function is now no longer in the context of object. It's now in the context of element whenever it gets called. However, if I do this as an arrow function, the context can't be changed, so this does actually get the name appropriately. So when you get to more complicated objects that are handling your elements, this becomes really useful because it means that things that normally would change the scope or the context of your callback functions can't do it anymore because of your arrow function. They're also just a little bit easier to write. So we have my method 2 with this a. If you only have one thing that you return, so return a over 2, and let's call this, my method 2. Oh, document is not defined. I mean, that makes sense. Let's just kill all this. All right, so we get 8, right? Let's turn this one off. Console.log. Oh, actually, I need to console log this. That's why it's not showing up twice. All right, and now it should just, oh, it's not a number. Oh, because I didn't give it a parameter. 8. Okay, so now if we're returning something from a arrow function, we don't actually need the return statement. We can just do this. Whatever this is, this single statement, the resulting value of it is what gets returned. I run that. Okay, 8 again. If you have a single parameter, you also don't need the parenthesis. Same thing. So you can see how this is much less typing than this. Much simpler. I personally don't do this because I think it makes the code harder to read, but it's possible. So if you really want to do it, you can. So that's one of the powers of arrow functions. They're a lot more concise. They're a lot easier to write. And most importantly, they hold on to context, which can be really useful in some cases. All right. So let's talk about rest and spread. So what is spread? Spread operator is something that can be done nicely on arrays and objects. So let's say we have an array 1, and we have 3, 4, 5, 6. But I want to have array 2, and I want it to be 1, 2, 3, 4, 5, 6. Okay, and I want to use array 1 to do that. So what I could do is I could just set this to an empty array. Then I could set it to an array of 1 and 2, right? And then I could actually go through item of array 1, and I could say, okay, array 2 dot push item, and at the end array 2 dot push. Well, I guess I don't need to do it. Let's say we have a 7 on there too. Array 1 dot push 7. Okay. Console.log array 1. Oops. No, this needs to be array 2. And this needs to be array 2. So what does that do? We start off with an array with 1 and 2. We push 3, 4, 5, and 6 from the new array, or our first array, and then we push 7 on the end. So if I run that, I get 1, 2, 3, 4, 5, 6, 7. That's a lot of code, though. That's an awful lot of code. So there's actually an easier way. And it's called the spread operator. What does this do? Well, if I just put array 1 as a parameter in here, let's just do that to start off with, right? Oops. And if I run this, now I have 1, 2, but then there's another array that has 3, 4, 5, and 6. It hasn't actually taken 3, 4, 5, and 6 and put them into array 2. It's put array 1 into array 2, which isn't what I want. But if I spread it with these 3 dots, now you can see it takes those things and it puts them into the original array, just like I did with my for loop. What's more, I can actually put more stuff after that, and it shows up just like it would before. So this is a much quicker way of kind of copying an array's properties onto another array. You can do it with objects too. 2 equals 1. And then I can say, let's see. Constant log object 2. I need a declaration here. If I run this now, you can see now that my object is both of these things together. If I didn't spread, I actually get a key called object1 and then the value being the value of that object, and they're not combined. It needs that spread. Oops. So the spread operator is the 3 dots. Now this is where it gets confusing because those 3 dots are used in other places as well. Let's say we have a function. I'm going to use an arrow function because we just went over those. Add. And I've got some parameters, B, C, D. And so what I want to do is I want to return A plus B plus C plus D, right? So I console log add, and I say, okay, add 1, 1, 2, 3, 4. And I got 10. But let's say I want to add 5, so I expect to get, that's not 5. 5, so I expect to get 15. I don't. Why? Because there's only 4 parameters in here. I could add a 5th parameter, I could add E, but that's kind of annoying for every single time I need to add a parameter. So JavaScript has a special way of handling this. It's called the rest, right? So I can actually do this, and now let me just console log the parameters, and then I'm just going to return nothing for a second. The parameters become whatever I pass in here, it gets put into an array. Oops. Right. Well, why don't you just pass an array into it? Well, because sometimes you don't want to do that. Sometimes you want to actually just do them as parameters. So now, no matter how many parameters I call this function with, they all go into the params, specifically because of these dots. If I take this out, params just becomes the first parameter. I need that dot in there. Why is it called rest? Because it takes up whatever parameters aren't named. If I have A, B, and C here, params is only 4, 5, and 6 because the first 3 variables are already taken. It holds whatever is left in the list. So let's say you wanted to do like math, and your first parameter was an operation, and the rest of it was the numbers to do on. And then you said, okay, add, and then numbers. Now I've got my operation. Whoops. Math. I've got my operation and then the parameters to work it on, very nice and neat, even though they were all just passed in like this. So you don't see rest very often. It's more likely used in like logging functions where you don't know how many parameters you're going to get. But it's kind of useful. All right, so final topic. Let's talk about destructuring. Let's start with objects. Foo, bar, key, value. So let's say I have an object with these 2 things, and I want to pull them both out into different variables. So I want a variable named foo that is equal to object1.foo, and a variable named key that's equal to object1.key. So I can say foo equals object1.foo, key object1.key. That should be fine. Then I add another parameter, okay, key2, value 2. And then I need to come, okay, const key2 equals object1.key2. This would get a lot to keep up if you keep adding stuff into it. So there's actually a better way. What you could do instead is destructuring. Now destructuring looks a little funny. You start out with curly braces on the left side. And then inside those curly braces you put the keys that you want to pull out of the object, to destructure. Okay? Now, what does that do? That is the same thing as creating an individual variable for each one. So if I console log foo, you can see it comes out as bar. This gets the value of object1.foo just magically. And how does it do that? Well, it knows that object1 is on the right-hand side, and it knows it's a destructuring because of the parenthesis. Not parenthesis, the curly braces. You don't have to put every key. If I leave key 2 out, it's going to be perfectly happy with that. You only need to pull the data that you need out of the object But if I do want to add key 2, I can just say, okay, yeah, key 2. It's very handy, right? You can also do this in functions. So I can have function do something. And let's say I call do something with object 1. Well, I could say input object, and then I could say const foo equals input dot foo. But I don't have to do that. I could also just say destructure foo. And there it is. It's just another variable. It's a variable that's part of this object. And this might be a little complicated, but basically just think about the property is an object that's coming in here, or the parameter, and so I can destructure that parameter into other things if I don't actually care about it as a whole, but I only care about a couple of things on it. You'll see this a lot when we get to React, and you might see it in some other libraries as well. So that's destructuring of an object. You just do your curly braces and then whatever the key has to match. Well, what if you already have a foo? Well, this complains. It's like, hey, that's already there. You can also rename it. If you do a colon, you can do that, and then there's two variables, foo and foo2. You probably don't need to do this. Oops, console.log. You probably don't need to do this super often. Let me just put something in there. There we go. Because usually you're not necessarily running into this problem, but if you do, you can rename what the variable name is going to be by doing this colon here, which looks very confusing because this looks like an object, but it's not an object. Thanks, JavaScript. You can also do this with arrays. 1, 2, 3. Now, instead of arrays, instead of the curly braces, you use square brackets. Then the name of the variable. See, this doesn't need to match any key because arrays don't have keys. The first property is going to go into A, the second into B, and the third into C. And here's a fun part. You can actually do a rest on C. What that means is that A is going to be 1, B is going to be 2, and C is going to be whatever comes after. So 3 and 4. So destructuring is really useful if you have a bunch of different properties that you want to pull off of an object or an array, and you just need to put names on them very quickly. And that's it. Those are the main ES6 stuff that you're going to have to deal with in your career. If you don't memorize them, that's okay, but it is good to recognize what they look like because this is what modern JavaScript looks like. Most modern companies are using this code. This is how they're writing their code. And so it's good to know how to do this stuff so that you understand how it works. Anyway, I hope that was helpful, and I'll see you all in class.